Thank you, Thomas. I hope you can see my my screen. So I would like to thank Felice for the nice presentation where he demonstrated how a predicted model like an naive-Bayes model can be implemented as a web service in Jackpot. So in this presentation, we're going to give some more details about the tool with my colleague Philip Doganis. What is Jackpot is a platform where you can deploy, share, discuss, and use predictive models. And in bullet points, in Jackpot, you can develop models in different runtimes and deploy them as web services, actually in a matter of seconds. Validate models and generate predictions using user-friendly interfaces. Make the models transparent to the users. We're providing different ways and flexibility for documenting the models. Share your models and make them accessible to users, collaborators, or groups. Integrate them with other applications and meet scalability requirements. This is important for model developers that we have developed this library where actually in a matter of seconds, actually just one line of code, you can automatically create a web service. And what I mean by web service, it is both an API and a user-friendly web interface. So I'm passing the presentation to Philip, who is going to give more details about the user interface. So Philip.
Hi, I hope you can hear me now. This is what the user interface of a model looks like when, of course, this is directed to a human user. We'll see how machine-to-machine interface and integration can occur. So this is the Predict Validate tab that we're looking at, where one can choose either to predict, create predictions, as we see on the right, and it's possible to do that either by manually entering the values, which is possible on the boxes on the bottom of the screenshot that we are looking at, and by using uploading CSV datasets. However, it is important to say that this one does not have to generate the datasets on their own, and also have in mind to formulate it somehow to be accepted. Jackpot generates the template automatically. It can be downloaded and re-uploaded again with the data filled in. The other option is validation, the validate option that we see here, and one can use an external validation dataset as input in CSV format. Of course, you understand that when something is available in that way and you can enter the data easily, it is possible to do the validation of a model. Harry, could you please move on the slide? Okay, it is possible to do the validation of a model you see that was created by someone else and test it on your data. So a model web page would look like that. It is possible to add model information in Markdown format, as we see more details on the Markdown format can be seen here. It's a rich format which allows you to formulate it so it's easier to read, and it can accommodate the QMRF report and everything needed to make it acceptable for more official uses. And on the right hand side of the screen, we see the Features tab of the model, where we can take a look at the dependent feature, which is the predicted feature, otherwise said, and the independent features. And for each feature, we can provide documentation, meaning we can provide the description, the units, and the ideological classes. Next slide, please. And after one has reviewed all that, after someone has provided data and tested the model on their own, it is possible to discuss the model, which is something needed to say that, okay, I tested that model, it works nice on my data, or it doesn't on this job by Einstein et al. For 2020. but on the other one, it didn't work. So that is a necessary element for us to be better in the community, to be better to better progress knowledge. Next slide, please. So one can do that by choosing which resources to share. And there is either a private space where I develop my models on my own and only I can see them. And there's a shared space where I can choose to share them with organizations, which are closed teams, closed groups, where I can choose to allow people to see my work. Right now we have one for NanoCommons, or you could create another organization in your internal team. Next slide, please. There are multiple examples of organizations, as we have seen, and one looks at the list of models, as we see on the right hand side. It is possible to see the list that you have. And on the top left, we see how it looks if you're looking at your private space. But you can change that by clicking on the arrow we see here, and you can choose to see your shared models and choose the organization, the subgroup which you want to view. Next slide, please. In order to be able to be actually usable, a web service and a platform that is meant for use in the internet speeds of deployment and usage, it is necessary to have what we call scalability, which means being able to respond fast to increases in demand by users. And do that in a way that does not hog resources, then does not require too excessive costs for maintaining that. That's why we have made everything used deployable but through containers, which are REST microservices, which can be scaled up or down to meet the demands. And on top of that, there are the layers of Kubernetes and OpenShift that allow the container management and incorporate high availability of the services. The integration can happen in a high private cloud or a public cloud. And here we see that this integration can be done through APIs, application programming interfaces, which allow machine-to-machine communication and integration. We have API clients for .NET, Golang, Java, JavaScript, and Python. Next slide, please. And one example we see here of the integration across multiple tools that has been implemented in NanoCommons is the NanoCommons risk assessment tool, where we have, it's a combination of Nanoinformatics tools available through NanoCommons, and it's a web app hosted and implemented within Nano's cloud. We start from 4 different exposure scenarios that have been simulated using the Guide Nano tool, which are fed to the Nanofaros database. The user makes choices about the scenarios and the parameters. PBPK models are, which we'll see on the next slide, are implemented in Jackpot. And through the web API, all of that is communicated to the Nanofaros risk scenarios and fed back to the users. The results are fed back to the users so they can perform risk assessment with the values they get. Harry?
Yeah, okay. So I will continue for some more few slides. Perhaps I can add here on a comment made by Sol before that through these APIs we can communicate with different sources of information, and we can integrate Jackpot with databases like Biomax or InanoMapper. So yes, that is possible. Philip mentioned PBKs. PBK models are supported by Jackpot, so we can develop and integrate biokinetics models that allow the user to simulate the response of organisms to different exposure scenarios and produce this concentration time plots. Actually, we have several TA projects that are running on developing and implementing PBK models. A recent development in Jackpot is the support of Bayesian network models, and this is quite important for safe by design, because we can ask questions and queries about how to design a nanoparticle so that it is safe and has low toxicological effects. So just to summarize, Jackpot is a platform where you can publish models as web services, implement models supporting materials to publications, collaborate with partners and colleagues, share models with colleagues and different groups, integrate models into other applications, and perhaps use it as a modeling environment. This slide contains a number of useful links, documentations, tutorials, material that can help interesting users to use this platform. And just I need to remind you that a model can be developed just by having a data set in Excel, running a Python code in Google, a very simple Python code in Google Colab. No installation is needed, and the result is a web service, an automatically created web service. That's the development team that are working very hard for developing and maintaining this platform. And thank you for your attention.